wants to go back and view our lecture from today, you will have the ability to do that. Okay, I forgot to turn on the recorder from until just now. So what I'll do is I'll go back and I'll record the topics that I covered before I realized this. So there'll be 2 recordings. Then I'll send out an email and remind you and all that good stuff. But from here on out, I am recording. So you can go back and look at today's session if you so desire. Okay, so again, hormone release is controlled mostly by negative feedback. There are some exceptions, but only one with respect to what the hormones we're covering, which is oxytocin. But the rest of them, receptor detects whatever the stimulus is, communicates to the control center. Control center causes the gland to release the hormone, and then it attempts to reduce the stimulus. Now, in terms of what are you required to know for each hormone, this is your list. So for each hormone that we're covering, you need to know the following: the organ that releases it, where that organ is located. And I mean in general where it's located. Like, I want you to know that the adrenal gland is found on top of the kidneys. Okay? We're not covering the endocrine system in lab. So in lecture, I do expect you to know in general where it's located in the body. I'd like you to know what tissue or organ the hormone targets, what stimulates that hormone to be secreted, what its effects are, its chemistry and mechanism of action, which we just talked about, and how it's regulated, how its secretion is regulated. And as I said, for all of the hormones, just about, it's going to be negative feedback. The only exception is oxytocin. Oxytocin is positive feedback, but all others is negative feedback. Okay? And so last week, I emailed you a packet that listed all the hormones, and it provided these tables for each hormone where you could go in and you can fill in this information as you watch the different videos. Okay, so I provided this to you because it provides a nice, easy way for you to organize the information that you have to know for each hormone. And we're going to do a couple of these today for the hormones that we're going to cover. Okay, before moving on, are there any questions? Okay, if there are no questions, we will move on to the next screencast. So the next screencast was insulin, glucagon, and diabetes. And specifically, the muddiest point that was indicated was for insulin and glucagon, describe the stimulus of secretion. Now, I'm actually going to cover most of this, because just to describe the stimulus of secretion just seems like I'm not doing justice to the topic. So let's jump into this. So your pancreas produces both insulin and glucagon. There are specific cells called beta cells in the pancreas, and in response to a rise in blood sugar, they release insulin. That insulin activates glucose transporters on cells all over the body, and it causes them to take up glucose. As those cells take up glucose, that causes a drop in blood sugar levels. Cells of the liver specifically take up glucose and they store it as glycogen. Remember, glycogen is This is like starch in a plant. Plants store glucose in the form of starch. Animals store glucose in the form of glycogen. So after you eat a meal, especially if it's high in carbohydrate, insulin is secreted. That insulin causes your cells to take up glucose to keep your blood sugar levels in a normal range. And specifically, it causes your liver to store that glucose as glycogen. It stores it as glycogen so that when you're between meals, that glycogen can be broken down to release glucose into your bloodstream so you can maintain your blood sugar levels even though you may not have eaten for a few hours. I'm not going to play this video on insulin, but I did place this video as well as the video I showed earlier about hormones and how they work on their target cells. I've placed those on Blackboard. I added a folder to your endocrine system, your endocrine system folder that you can view, and they're all YouTube videos and they're closed captioned. So that's where you'll find them. Okay, so that was insulin. What about glucagon? Well, glucagon is a hormone that is antagonistic to insulin, meaning if insulin reduces blood sugar levels, what's glucagon going to do? It's going to increase blood sugar levels. Now, glucagon is produced also by the pancreas by what are called alpha cells, and glucagon is released in response to a drop in blood sugar levels. So if you're between meals, you haven't eaten in 3-4 hours, you're not getting glucose being absorbed from your small intestine, so because you haven't eaten in a long time, and so your blood sugar levels start to fall. To maintain blood sugar levels, those alpha cells release glucagon. The glucagon targets the liver that stored that glycogen, and it says, hey liver, blood sugar levels are dropping. Now it's time to break down that glycogen to release glucose into the blood. Okay? So glucagon and insulin are antagonistic. They control the same variable, but they have opposite effects. You can almost think of them as sort of like your brake and your gas. They both control velocity of your car, but they have opposite effects, and they counterbalance one another so that blood sugar levels can remain in that normal range because they're critically important. Both of them are regulated by negative feedback. This figure right here is the most important figure for making sure that you understand the effects of of insulin and glucagon on blood sugar levels. It illustrates how they maintain blood homeostasis. So if you can explain this figure as I'm about to, any question I throw at you on about insulin or glucagon, you should be able to answer. So blood sugar has this normal range, right? And so we'll say if it's in the normal range, then blood sugar is at homeostasis, or we have blood sugar homeostasis. Let's say you eat a jelly donut, right? Lots of carbohydrate. Well, what's going to happen? Blood sugar levels are going to increase. That's the stimulus that causes beta cells of the pancreas to release insulin. Insulin is going to cause pretty much every cell of the body to take up glucose, and it's going to cause liver cells specifically to take that glucose up and store it as glycogen. By causing uptake of glucose as blood glucose levels rise, it's going to bring glucose levels back down to the normal range. Okay? So insulin is released shortly after you eat to bring blood sugar levels back down to the normal range. And that's why we call insulin the hormone of feasting. Now, let's say you're between meals. You haven't eaten for 4 or 5 hours. Well, you're not going to have carbohydrate being absorbed from the small intestine because there's none there. Or let's say you skipped a meal because you've been studying A&P so diligently all day, right? Your blood sugar levels are going to start to fall. That drop in blood sugar or blood glucose is going to be detected by the alpha cells of the pancreas. They're going to release glucagon. Glucagon is going to target that liver that stored glucose as glycogen after you ate that jelly donut. And it's going to cause the liver to break down that glucose and release it into the bloodstream, bringing blood sugar levels back up to the normal range. Because glucagon is released when blood sugar levels fall, glucagon is described as the hormone of fasting. Okay? All right, so that's the story of insulin and glucagon and how they maintain blood sugar homeostasis. Okay, so I want to pause and open up the floor to any questions you may have. No questions at all, huh? I was going to do another poll, but I can't remember how I got to that option. That's okay. I found it. I'll wait till the next one. Okay. So the next screencast was on anterior pituitary hormones. And the question, the learning objective that was noted as a Medius point was describe the anterior pituitary gland and its secretion of hormones in response to the hypothalamus. Okay, so the anterior pituitary gland is a extremely important gland. It produces 6 hormones, and 4 of those hormones are tropic hormones, and they're related to many of the other hormones that you had to learn about, including thyroid hormones, the sex hormones, the adrenal hormones, the adrenal corticosteroids specifically. So let's talk about those. Okay, so this is the hypothalamus, and this is shown here in, what is this, magenta, purple? I don't know, the anterior pituitary gland. The anterior pituitary gland produces 6 very important hormones. They include growth hormone, prolactin, follicle stimulating hormone, thyrotropic hormone or thyroid stimulating hormone, and ACTH, adrenocorticotropic hormone. Growth hormone and prolactin are not tropic hormones. They affect tissues and glands that don't produce hormones. However, these 4 are tropic hormones. Follicle stimulating hormone and luteinizing hormone target the testes and ovaries, and those glands, those organs, I should say, not glands, those organs produce sex hormones. So FSH and LH are tropic hormones because they target organs that themselves produce hormones. Thyroid stimulating hormone targets the thyroid, and of course the thyroid produces thyroid hormones. ACTH targets the adrenal cortex, which produces hormones. So these 4 are tropic hormones. Now, what do all of these hormones have in common? Quite a bit, actually. First, they are all released in response to hormones from the hypothalamus. So it is hormonal stimuli that causes them to be released. The hypothalamus sends hormones to the anti-pituitary gland and says, hey, release this, or release that, or release that, or release that, or what have you. Second, all of these hormones are non-steroidal, meaning they work through second messengers. They are all regulated by negative feedback. The only areas where they differ is what they target and their effects. Otherwise, in every other aspect, they are the same. So for all 6 of those hormones, they're all produced by the anti-pituitary gland. They are all released in response to hormones from the hypothalamus. They're all non-steroidal, which means they all work through second messengers, and they're all regulated by negative feedback. The only thing that's different is what organs they target and their effects. Okay? So, for those of you who listed that as the muddiest point, does this make more sense to you? What questions do you have? Everybody's so silent. No questions at all? Okay, I will move on to the next next topic, rather. All right, the adrenal glands. Specifically, several of you had questions about the hormones released by the adrenal medulla, which are epinephrine and norepinephrine. And there was one question about the adrenal cortex. What I would say is that due to lack of time, if you have a question about the adrenal cortex specifically, let's talk about it at the end of the class today. So I'm going to focus specifically on this learning objective here. So let's talk a little bit about the adrenal glands in general. So the adrenal glands are found on top of the kidneys. Kidney means renal, or another term for kidney is renal. So either easy way to remember that where the adrenal glands are found, just think you add them to the renal, you add them to the kidney, adrenal. Now, the adrenal glands, like the pituitary glands, we named it before we really understood what it did. The adrenal glands are really 2 organs in one. Really, the adrenal cortex, which is the outer portion, is composed of glandular material, and it's a true endocrine gland. The medulla, the inner portion, is really composed of modified post-ganglionic cells of the sympathetic nervous system. They're really neurons that, instead of releasing neurotransmitter, release hormones. The adrenal medulla produces the hormones epinephrine or adrenaline and norepinephrine, and they release them in response to stimulation from the sympathetic nervous system. If you recall, the sympathetic nervous system is the portion of the autonomic nervous system that prepares the body for increased activity. It causes increase in heart rate, increase in respiration rate, dilates the respiratory passageways, dilates blood vessels to skeletal muscles, preparing your body for an increased level of activity. Okay, the extreme of that would be fight or flight, right? When you are or feel you are in peril. The sympathetic nervous system also stimulates the adrenal medulla to release epinephrine and norepinephrine into the blood. And as it circulates through the blood, it has pretty much the same effects that epinephrine as a neurotransmitter has. It increases heart rate, it dilates blood vessels that supply blood to skeletal muscles, it increases respiration rate, it dilates the respiratory passageways, right? What these hormones from the adrenal medulla basically do is they reinforce the activity of the sympathetic nervous system. The epinephrine or adrenaline that's released by the adrenal medulla is the same chemical as the neurotransmitter. There's no difference. Just that when it's released at a synapse, we call it a neurotransmitter. When it's released into the blood, we call it a hormone. But they're both chemical messengers and they work the same way and have the same effects. Now, you'll sometimes hear the adrenaline and noradrenaline or epinephrine and norepinephrine referred to as the catecholamines. They are amines, they're modified amino acids. And so don't be confused by this terminology. Catecholamines is just a word that includes adrenaline and noradrenaline. All right, but the effects that they have, same effects that you find for the sympathetic nervous system: increased heart rate, increased blood pressure, dilates passageways to the lungs, increased oxygen and glucose availability to your brain, your heart, your skeletal muscles. Right, this helps you deal with whatever the challenges you're having at that time. Reinforces the actions of the sympathetic nervous system. Right, I just want to highlight that these hormones are released by the adrenal medulla, not to confuse it with the adrenal cortex. The adrenal medulla, and they're released in response to the sympathetic nervous system. Okay, now let's go to our hormones and their properties table. So the organ of secretion is the adrenal, I shouldn't say that, not adrenal gland, we're going to say adrenal medulla. Let's be a little more specific than that. Bad Chuck. All right, better. The adrenal medulla. What causes, stimulate secretion? Sympathetic nervous system. Non-steroidal, so the mechanism of action is going to be what? Second messengers. Target organ of secretion, well, it's going to be various. So don't worry about that. I'm not going to have you nail down any particular organ on that. Okay. Effect, it reinforces the effects of the sympathetic nervous system. And how is it regulated? Negative feedback or positive feedback? Well, technically, it doesn't have any feedback. When the activity of the sympathetic nervous system drops, then there's going to be less release. Okay. Now, I know I said just remember oxytocin is positive, everything else is negative, right? This is an exception. There is none. I will not ask you if this is positive or negative, so don't even worry about it. Okay, questions before we move on to thyroid? Okay, for thyroid hormone. So the question is, where I say the worksheet is. I emailed you the worksheet last week, or actually, when did let me think. When did I email it? Yeah, it would have been last week when I. So check your email. just like today, I emailed you a learning activity for the cardiovascular system. And oh, there's no attachment? Okay, well, I'll take your word for it. I will send it again. That will be easy enough to do. So I'll send that as soon as we're done today. I was gonna say I'll resend it, but I will send it for the first time. If I did not send that, I do apologize. I sent it to my other class that I do know, but I did not send it to you guys. I do apologize for that. Okay, thyroid glands. So the learning objective that you indicated was the muddiest points was list the 2 thyroid hormones and describe the following, right? Stimulus of secretion, chemistry, target tissues, regulation, the typical stuff. So, all right, so this figure here, let me orient you. So here is our, here's the brain. This right here, of course, is the pituitary gland. Pituitary gland extends from the hypothalamus as shown here. So this is a blow up of that. So here's your hypothalamus. Here's your anterior pituitary gland. The hypothalamus secretes thyrotropic releasing hormone, also called thyroid stimulating hormone. Excuse me. Oh, I'm sorry. I'm messing this up. The hypothalamus releases thyroid releasing hormone. You don't have to know that, but it does. It releases hormone onto the anterior pituitary gland. The anterior pituitary gland then releases thyroid stimulating hormone. Thyroid stimulating hormone, as the name implies, targets the thyroid gland and causes the release of T3 triiodothyronine and T4 tetraiodothyronine. And you can just call them T3 and T4. These are the thyroid hormones. So when you hear someone talk about thyroid hormones, they're talking about T3 and T4. T3 and T4 are released in response to thyroid stimulating hormone from the anterior pituitary gland. Okay? So your thyroid gland is inferior to the thyroid cartilage. The thyroid cartilage is basically forms the anterior surface of your Adam's apple, right? So if you find your Adam's apple, then all you have to do is just move down and you can find your thyroid gland. Your thyroid gland looks very similar to, well, sort of Madison. You have the isthmus in the middle, and then you have east side, and then you have the west side. The thyroid gland produces T3 and T4. It also produces calcitonin. However, when people talk about thyroid hormones, they're talking about T3 and T4. And that's what we're talking about at this time. T4 is thyroxine or tetraiodothyronine, and T3 is triiodothyronine. Now, why do we call them T4 and T3? Well, it's because a molecule of T4 contains 4 atoms of iodine, and a molecule of T3 contains 3 atoms of iodine. In fact, most iodine in your body is found in these molecules in your thyroid gland. And that is why, for the most part, you have a iodine dietary requirement, because iodine is required for the production of these thyroid hormones. So what do these thyroid hormones do, T3 and T4? Well, they cause the the oxidation of glucose to make ATP, and then the utilization of ATP by cells. So they basically increase the metabolic activity of cells. In terms of their target cells, pretty much every cell in the body is a target cell for T3 and T4. And what we know is those tissues that have a high requirement for energy are affected if we don't have normal levels of thyroid hormones. The reproductive system in an adolescent can fail to develop normally and may be non-functional if sufficient levels of T3 and T4 aren't produced. Same thing for the nervous system. So going to this table, what's the organ or gland of secretion for T3 and T4? It's going to be the thyroid gland. What stimulates its secretion? Thyroid stimulating hormone. Its chemistry is non-steroidal. However, if you remember, this is the only exception to the rule about chemistry and mechanism of action. Even though it's non-steroidal, it does bind directly to DNA. All cells are the target. Its effect, it increases the use of ATP by cells, it increases metabolism, and it's regulated by negative feedback. Okay. Any questions at this time? Okay, next week I'll make sure that we have a more interactive discussion. I'll have some interactive activities prepared so that it's not all me lecturing and you just sitting back and going, yeah, I understand everything. Not complaining. I just want a little more interaction between us, but I'll be better prepared next week. I'll return to the topic. All right, calcium homeostasis. Now, when we talk about calcium homeostasis, what we're talking about is maintaining normal levels of calcium in the blood. If you recall, when we were covering the skeletal system, I mentioned that blood calcium levels are very important. Calcium is important for maintaining proper activity of the nervous system. If calcium levels get too high or too low, your nervous system can become hyperactive, or you can actually go into a coma and possibly die. Calcium levels are important for blood clotting. They're also important for muscle contraction, including that of the heart. So calcium levels are maintained in a very narrow range by the human body. Also, if you remember, most of the calcium in your body is found in your skeletal system. So if you're not getting sufficient amounts of calcium in your diet, your body's going to take that calcium off your bones to maintain blood calcium levels. And the way it does that is through hormones. The learning objective here lists the hormones that maintain blood calcium homeostasis. Those two hormones are parathyroid hormone and calcitonin, but we'll also talk about these other aspects of them as well, and also vitamin D. Okay, so I mentioned that that calcitonin is produced by the thyroid gland. We don't consider it a thyroid. It is a hormone that's produced by the thyroid gland, but when you hear the term thyroid hormones, calcitonin is not typically what it's being referred to. That is T3 and T4. But it is produced by the thyroid gland. It's produced by other cells in the thyroid gland, but it is released by the thyroid gland. Calcitonin is released in response to high blood calcium. So if you ate a meal that was high in calcium and your blood calcium levels increased, calcitonin would be released by the thyroid gland. This figure here shows the effects of calcitonin. Calcitonin, in response to an increase in blood calcium levels, is going to stimulate those osteoblasts to take calcium from the blood and put it on the bones. So calcitonin is going to cause an increase in bone density. calcitonin is also going to increase the removal of calcium from the blood by the kidneys and therefore increase the calcium lost in urine. Again, remember, calcitonin is it was secreted in response to high blood calcium levels, so it's going to respond by decreasing blood calcium levels. So this is your thyroid gland, located on and sometimes close to the thyroid gland are what are called parathyroid glands. And parathyroid glands, of course, are going to produce parathyroid hormones. Parathyroid hormone is antagonistic to calcitonin. Calcitonin causes a decrease in blood calcium levels. Parathyroid hormone increases blood calcium levels. Parathyroid hormone causes the osteoclast to dissolve the bone, remove calcium, releasing it into the blood. It also stimulates the kidneys to reabsorb more calcium from what it removed from the blood to keep calcium levels in the normal range. Okay, so parathyroid hormone is going to increase the activity of osteoclast, so it's going to increase bone resorption. It's also going to cause the kidneys to return more calcium that they remove from the blood. We haven't got to the urinary system yet, but the way the kidneys work, they filter the blood and then they reabsorb most of what they filtered, right? Parathyroid hormone increases the amount of calcium that is returned to the blood by the kidneys. Parathyroid hormone also enhances absorption of calcium from the small intestine. Parathyroid hormone, by the way, is the hormone that is responsible for osteoporosis. If you're not getting sufficient amounts of calcium in your diet, then you're going to have high levels of parathyroid hormone all the time. And so you're going to get this bone resorption occurring all the time. And over a prolonged period of time, that can cause a drop in bone density such that your bones are prone to fractures from just normal body movements. Now, students often mix calcitonin and parathyroid hormone up. They remember that they both control blood calcium levels, but they can't remember which one raises it and which one lowers it. So what I tell students to remember is parathyroid hormone increases blood calcium levels, calcitonin tones it down. So that's a way you can remember. This figure here, much like the figure on blood glucose homeostasis, is great for making sure you understand the role that calcitonin and parathyroid hormone play in maintaining blood calcium levels. Blood calcium, let's say you had a big glass of milk and your blood calcium levels rise. Thyroid glands are going to release calcitonin. That calcitonin is going to stimulate the osteoblasts to take that calcium from your blood and deposit it into your bones and bring your blood calcium levels back down to normal. On the flip side, if you're not getting enough calcium in your diet, let's say you go all day or a couple of days, eat anything that has calcium in it, blood calcium levels are going to tend to fall. And that's going to cause release by parathyroid glands of parathyroid hormone. That's going to cause those osteoclasts to break down the bone, releasing calcium into the blood. That's going to bring blood calcium levels back up to the normal range. Okay. Just a note: calcitonin, believe it or not, is not required for life. So if your thyroid gland is removed, there doesn't have to be a exogenous replacement of calcitonin. You don't have to take medication to replace the calcitonin. However, we do know that parathyroid hormone is required for life. Removal of all your parathyroid glands results in death within 3 days. How do we know this? Well, there was a time we did not know the parathyroid gland existed. And so some patients would have their thyroid gland removed for various reasons. And if all of the, and some of them would die within a few days. What we came to learn later was there were these other organs, these other glands called parathyroid glands, and in some of those patients where the thyroid gland was being removed, the parathyroid glands, all of them were being removed as well. All right, last topic, and it's a quick one. Under the gonadotropins screencast, there was one muddy point, and that was describe the events. Describe the events that leads to the secretion of the gonadotropic hormones. Really, all I want you to understand is that the gonadotropic hormones are released by the anterior pituitary gland, and they're released by the anterior pituitary gland in response to hormones from the hypothalamus. And you don't have to know what hormones it is. They're called gonadotropin releasing hormones, but you don't have to know that. All you have to know is there's hormones from the hypothalamus cause release of luteinizing hormone and follicle stimulating hormone. And then those hormones target the ovaries in females, leading to the release of progesterone and estrogen. In females, this whole process is cyclical at certain times of the month. These hormones from the hypothalamus are at higher levels, and therefore LH and FSH are at higher levels than at other times of the month. Progesterone and estrogen feed back onto the pituitary gland and the hypothalamus. This is classic negative feedback. So as estrogen and progesterone levels rise, there is less release of LH and FSH. There is less release of these hormones from the hypothalamus. The way the pill works is certain time of the month, the pill contains progesterone and estrogen, and so those levels rise in the blood, and that reduces the release of LH. And LH, a high level of LH is required for ovulation. And so by taking an outside source of progesterone and estrogen, the body is sort of fooled into thinking that the patient or that the individual is pregnant. And so you don't get this LH surge, you don't get ovulation. If you don't have ovulation, there's nothing to be fertilized, and therefore there's no pregnancy. Okay. In men, in men it's similar. Again, the hypothalamus releases hormones onto the anterior pituitary gland, which causes release of LH and FSH. Okay, it's not so cyclical, however. It's more, as far as I know, I'm not up on the latest research. As far as I know, it's pretty steady through from day to day. Okay, so I went over by a couple of minutes. I apologize for that. So at this time, I'm going to open the floor up if there are any questions. As I said, I will send you that. I will send you those tables by attachment. I also will, I've recorded this session, and I will post that to Blackboard. When it's done, I'll send you an email letting you know that it's done and where you can find it. I also wanted to show you where while I have you, where the videos are that I mentioned earlier. So if you go to lecture, and you go to the endocrine system, and you scroll down here to the bottom, you'll see videos, endocrine system, and so far I have another one I'm going to post, but so far I have hormones, steroid hormones, and non-steroid hormones. There's a couple more I'm going to post. Okay, so I'm going to open up the floor. Any questions you have whatsoever? I am going to stop the recording, however.